Hello, teacher and all friends in this group. Today I'm gonna take a presentation about my topic. And at first, I wanna thank to lecturer for giving me this topic and to make me have the opportunity to make this presentation. And my topic is about the fire test of steel. Yeah, we will talk about the process and talk about the something that the method is going on. Um, it is about the construction introduction. Yeah. Um, the fire test. The fire test is it is one of the destructive method, and it is used to investigate the behavior of structural steel in natural fire. And yeah, a series of large compartment fire tests carried out between 1983 and 1986 to investigate the behavior of structural steel in natural fires. A typical building contains a range of components and material designers and developed to enable designers to meet their legal obligation outlined in the building regulations to create a safe and healthy environment. Those components which have a function in enabling the building to meet the performance and to meet the requirements for life safety and property protection in a fire must have a comparable standard of performance and must be fit for purpose. To demonstrate this, it is necessary that this material and components undergo a several tests, and that this test sets a common benchmark. To enable this to happen, standard fire tests which meet this criteria have been developed and uh, codified. Yes, codified. And let's move to the next part. We talk about the process of the standard fire test. This is the time. This is the time temperature relationship in standard fire test is internationally recognized and is the same regardless of the test standard just that it show below. Yeah, and this is the graph of the fire test. And let's move to the next part. We will talk about the standard fire test is yeah. However, furnaces, which are normally very similar, can give a very different result in a test. There are a number of reasons of this. And the first reason is it is possible to use different control mechanisms. This means furnaces where the temperature is measured by, for example, a small bed thermocouple will respond very quickly to changes, especially in the early stage of a test, and we require only small increases in fuel input per unit change in the temperature. Um, the other is furnace where the thermocouple is in the form of a plate. This presents a large area to the furnace, which responds much more slowly than a smaller bed, and therefore tends in furnaces controlled by a large heavy thermocouple will be much more safer than those are controlled by the smaller, yeah, and more responsive wet thermocouple, although both normally follow the same time temperature relationship. Yeah, this is the first reason, and the second reason is uh, um, about the gas or oil. Depends on gas or oil. Um, the reason why apparently similar tests give very different result is the fuel just. This is usually gas or oil that I said before. Uh, gas fires, gas-fired furnaces usually produce a clean environment in which the main mechanism of heat uh, transfer is radiation from the wall to the test specimen. Oil fire furnaces can produce environments full of incandescent carbon particles which radiate to the specimen at higher temperature than the walls, and therefore an oil fuel furnace will tend to be more safer than a gas fire equivalent. Yes, equivalent. And yeah, let's move to the next point. Yeah, this is the picture that show about a horizontal furnace typical for testing floors, slabs, and beams. And the right one is a vertical furnace typical for testing doors, wall assemblies. Yes, sorry. And the next point is this is a picture about inside the furnace during a fire test on a pre-protected beam. Yeah, this is a beam, and yeah, this is inside the furnaces during fire test is going on. Let's move to the next point. We talk about the success and failure in fire testing. The report of fire resistance tests generally outline results expressed in terms of time to failure against one or more of three criteria for the product or element being considered. The performance criteria are the first one is load bearing capacity. This means that the ability to support the applied load and to resist collapse. The second one is we talk about integrity. It means that the ability to resist the passage of flames or hot gases. Yeah, in integrity failure is determined by an ignition test using a cotton pad or penetration of a gauge into penny, or by the present of the sustained flaming through an opening. Yeah, this. And let's move to the next point. Is the third point is insulation. This means that the ability to restrict the temperature rise on the unexposed face. Insulation failure occur when the average temperature rise on the unexposed face exceeds 140 degrees Celsius above the initial average temperature, and at um, no point is the temperature increase allowed to be greater than 180 degrees Celsius above the initial average temperature. Yeah, and this is the picture that show the transformation of the fire, yeah, at Broadway Plus 8 in London. Um, the building was only partially protected, and based on the performance of individual element, tests should have collapsed. However, it did not so did not do so, and exhibited considerable robustness. The damage shown here was repaired and the structure reinstated. And yeah, the last I wanna thank you to teacher and all friends in this group for watching this video. I hope this video can make you understand this method about the fire test.